Welcome to this presentation on K step ahead prediction models. We will first motivate it, derive it, present an example and Scilab code. We will explain it using the Ormax model first. Ormax stands for ARMA plus exogenous signal model. Ormax denotes ARMA plus exogenous signal. This A denotes autoregressive AR, this C denotes moving average or MA, this B denotes exogenous or X. U is the input, Y is the output, C is white noise and K is the delay. A, B, C are polynomials in Z inverse. We factor all delays into K, so the constant terms of A, B, C are not 0. Constant terms of A and C are 1, that is A and C are monic. This is something we have already seen before. If there is any change, we can incorporate that into the variance of C. Now we will explain the K step ahead prediction error model with the Ormax that we saw in the previous page. Here is the key observation: any change in U can affect Y only after K samples because of the delay of K here. But unfortunately, the noise starts affecting the process right away. We want to get the best estimate of the output so as to take corrective action starting now. That is, we want to take corrective action right away, even though it is effect is going to be felt only after K samples. For that, we first write in terms of n plus j. So we put this plus j here in every term. We want to do this from K onwards, but we generalize it in terms of j. So we want to predict output from n plus K onwards or n plus j, j greater or equal to K. As far as today's lecture is concerned, we need only j equals K case, but we would like to generalize this for all j greater than K. This will be useful for the next week and so on. Alright, let us take this example again and we write it in the form of A in the denominator, that is divide throughout by A. If C equals A, that means there is unity here, then the best prediction model is, remember this is white noise, so the best estimate of just white noise is 0. You get this? Of course we are assuming that it is 0 mean. White noise is of 0 mean, so its mean is 0 here. So this is the best prediction model. What will happen when C is not equal to A? Let us take the case of C not equal to A and let us take J to be greater or equal to K. This term, the last term, has both past and also future noise effects. Why is that? Because this polynomial C has z power minus 1 and its powers. As a result, some of those factors could take this back in time. To see this more concretely, let us divide C by A and write it in this fashion. Basically, you divide C by A and write the quotient as Ej, and the remainder is the second term that includes Fj. Fj is the remainder multiplied by z power minus j. Now when I substitute this back into this, into the first equation, the first term remains as it is. In the place of C by A, I substitute this is E and this is F by A times C, which comes from here. So all that I have done is I have divided C by A and written these two terms. The last term here has z power minus j outside here. Z power minus j affects all the terms here, that is, it multiplies every term here. You can see that you have powers up to j minus 1, z power minus j minus 1, here z power minus j onwards. Alright, so I have reproduced the same equation here. The second term has only future elements, that is this multiplied by C of n plus j. How do we see this? Just multiply this. So the second term is, the first one is E of j0 times C of n plus j. The next one is Ej1 C of n plus j minus 1, because you have z power minus j. You continue this all the way up to C of n plus 1. The current instant is time n. We are talking about n plus 1, n plus 2 all the way up to n plus j. As a result, these terms contain only future noise effects. So these are all future. As a result, this contains past effects, because notice that these have larger powers of z power minus j. As a result, the third term is known from previous measurements. Can I substitute here and simplify it? That is what we would do in the rest of this lecture. Alright, first we would take a simple example. Here is numerical example given, and we are asked to split C into Ej and Fj for j equals 2. Okay, shall we do that? So let us divide by A. Okay, C is given here 1 plus 0.5 and A is given here. So we want to take only this fraction and then divide this into Ej plus z power minus j into Fj by A. I have done it by long division. It is straightforward. Let us just go over that. 1 plus 0.5 z inverse is to be divided by the denominator term, which is here. So you have 1 here, you have 1 here, so I get 1 here. So 1 times this whole thing, I write this whole thing and I subtract it. So this will become 1.1, this becomes plus 0.16. Here I have 1.1 z inverse, I have 1 here, so I have to put 1.1 z inverse. When I do that, I get 1.1, then 1.1 into minus 0.6. Similarly, I have here, I subtract it, so I get plus 0.82 z power minus 2 plus 0.176 z power minus 3. Now all terms have z power minus 2 or higher, so I stop here because j is equal to 2. If j were 3, I would have done one more step and I would have gotten the next remainder, which will have z power minus 3 or higher in every term. So I stop here and I write it in the form of Ej and Fj. This quotient is Ej, which is given here, and the remainder is what I obtained here. Remember, I have to pull out this z power minus 2 here, so I get this term. So I have divided C by A into Ej and z power minus j Fj by A. Here is the Scilab code given. It is called recursion underscore ex1 dot SCE, and it computes E and F recursively. Okay, it continues here. When I run this, I get the following output from Scilab. See that Ej is 1 and 1.1, 1 plus 1.1 z inverse, Fj is 0.82 plus 0.176 z power minus 1. This is in agreement with what we saw when we obtained these results numerically. So this is the effect of that long division. So that is, this term C by A has been divided like this. So let us substitute it in the expression for y of n plus j, with j equals 2. that is the reason why we stopped at z power minus 2. So we get y of n plus 2 equals, the first term does not change and I substitute j equals 2, it becomes u of n, no change here, and then for this I substitute the first term, which is this, multiplied by c of n plus j, n plus 2 here, j equals 2, and similarly the third term becomes like this, and the second term is unknown. It is clear here, this will have c of n plus 2 when I multiply it out plus 1.1 into c of n plus 1. So as a result, these are future terms. Second term is unknown, the last term is known. So let us split noise into past and future for the general case. Okay, if we first wrote this as y of n plus j, and then I have taken this a onto the right hand side and split this c by a into ej plus z power minus j into fj by a. Then I multiply this out. So I write this term first, fj by a into c of n, because you have z power minus j, you have plus j here, they cancel each other, and the third term comes here. Okay, now for c of n I substitute from here, which is a by n minus bu n minus k divided by c. There is no change in any other term. So let us multiply this out and take out this u term here. So this is fjb into ac, and there is a minus term here, so it comes here into u of n minus k, and this a and a cancel, fjy by c is coming here. There is no change in the last term or first term. So now I group u terms here, b by a into u, and there is a 1 here, this is for the first term. For the second term, if I just multiply, I have bfj ac, bfj ac, when I have z power minus j, it will cancel this and I will get this n minus k. There is no change in the last two terms. Let me simplify this now. Recall how we got ej and fj by dividing c by a. So from here c by a minus, you bring this to the left hand side, equals ej. So c by a into this whole thing is ej. I have pulled out c by a, c is not there, so c comes in the denominator. Alright. Now when I substitute it here, I get y of n plus j equals ejb by c. All that you have to do is, you want only this, what is in the bracket is eja by c, I substitute eja by c, a and a will cancel, and so we have ejb by c times u of n plus j minus k. So there is no change in other terms, write down as they are. The last term has only future elements as we discussed earlier, because it has only polynomials, but then only up to powers z power minus of j minus 1. So it has all future terms, hence the best prediction model is given now. What do you have to do? 0, because these are all future noise terms, every element is white noise, so as a result it becomes 0, and this is the best prediction model. This hat means estimate, we have seen this usage before. Vertical line n means using measurements available up to and including n. There is another method to split c by a into ej and fj. Okay, there is an easier method, although it might be computationally little more expensive. Just cross multiply by a. So it becomes c equals aej plus z power minus j into fj. In this polynomial equation, c, a and z power minus j are known, ej and fj are to be calculated. I want you to think, how would you solve this? Concluding remarks, prediction error model is necessitated by the delay in the plant. predict the effect of the noise and take corrective action. Use of PEM will be explained in the subsequent lecture. It should be understood that in the previous week we discussed one step ahead prediction model. There we assumed the delay was just 1 unit. Here we have generalized it for k delays, delay of k samples. We will explain the use of this prediction error model in subsequent videos. With this, we have come to the end of this video. Thanks for joining. Goodbye.